Hello, this section is a continuation of core concepts. Understand the Kubernetes API primitives. In this actual article, we're basically going to talk about Helm, which is a third-party library. And in this newest release, version 3, it's just basically a set of command line tools, or a single command line tool that interacts with Kubernetes through the Kubernetes API. Just so you know, in previous version 2, there was also a server component, which we're not going to be using, right? We're using version 3. And so that server component used to be called Tiller, by the way. So we're not using that. The main concept for Helm is it allows you to install applications, which are really just groupings of Kubernetes resources, just like kind of like we did with the last example where we had a folder with more than one resource. In this case, though, it has some features that let you manage those resources in a much more controlled way, and we'll do it by example. The main concepts for Helm is, the first is called a chart, which is essentially that application. It's just a grouping of resources that you're managing. They actually have a concept of a repository, because in addition to managing packages, you can actually, or manage your application, you can actually install, treat this as like a package manager to install third-party packages or third-party charts into your project. We're not going to really cover that in this video here. We're just going to really focus on the application management features. And the last concept, and again, this will be more clear through example, but we have what's called a release. So the idea of the release is an instance of the application running, and we'll see you can actually run multiple instances or multiple releases of a single chart. So think of it as basically, right, one is the application running, which is the release, and the application kind of to be installed is the chart. Okay, so we're going to go through all this through example, and we're going to create our own Helm chart. So the first thing you need to do is actually install Helm. Let's see. And I'm going to actually be honest, you're going to basically just go to Helm. Actually, I'll go there myself. Right? If you go to Helm, Docs, let's see if I can get to it. Introduction, I believe it's probably under Introduction, installing Helm, right? So you'll do that on your own. So I already have installed Helm on my machine, and okay. Now, just a side note, if you were thinking about this, if we were trying to do similar sort of things, where we're managing multiple releases of the same application, but we were just using regular old cube control like we were doing before, I guess conceptually you'd have to almost manage different folders. You would take a folder, build an application, and then you would clone the folder, and then you have to change all the resource names because you don't want duplicate resources, or you'll have to deploy in a different namespace, and so you're going to have to make a bunch of changes, and now you basically have two folders that are essentially the same quote-unquote application, right? So it would be clumsy, a lot of search and replace, right? So we'll find out that Helm solves some of those problems for us. And it actually solves some other things too that we'll see. Okay, so the first thing we do is we're going to create a project. And I'm going to go in here, and in the repository for this, there's an actual project sample, which is the final result of our exercise. So if you wanted to look there too, but I'm going to create the project here, and then I'm going to remove it. But okay, so the command is called Helm create, and you name the project. In this case, I'm being boring. I'm calling my project, or my chart is called project. Okay, so you're actually creating a Helm chart. So let's look to see what's in it. Let's look to see what's in there. So a couple interesting things is, which I find somewhat unfortunate, but they provide sort of a sample application already installed when you scaffold up this chart. So you've got, like, you look in this templates, there's all sorts of templates already in place, and it's like you're not sure exactly what all this stuff is. The good news is that you can just go into templates, and we're going to remove everything. Move star. remove tests. So I'm going to start off with an empty template. And values is full of stuff. And we're going to get rid of everything here. So basically now we have an empty values, an empty templates. We do want to make one change to there's a chart YAML, which is essentially the kind of the package definition file. And it's more or less fine. So the name of the project is called project, right? I'm not going to leave I'm going to leave the description alone. And the one thing I am going to change is this app version, just to make it the same as version. Now, what's a little confusing is, and to be honest, I'm still a little fuzzy in my brain. The rules generally are suggested to be that every time you change your chart or your definition of your YAML files, right, you're supposed to up the version number by convention. Then separately, there's a concept of app version, which they're suggesting that is a different number, right? This is every time you deploy a new application. So to me, they're conceptually the same thing. Version is required, app version is not. So I'm going to leave it, I'm going to treat them both the same for now, and I'm going to up them exactly the same. So I'm not going to differentiate between the two. Now, and actually through all these examples, to save time to boot, I'm not going to actually change these values. They're not, you don't actually have to change them. We'll find out that there's other mechanisms that Helm uses to kind of version control things separate from these numbers. But in practice, you should be upping these numbers every time you make a change to your chart. So again, we're not going to do it, but that's what that is. Okay, so now we have a clean setup. Charts, just so you know, charts is empty too. Okay, so we're going to make some edits here. So make sure I didn't miss anything. Yep. So the first thing I want to do is I'm going to create a new entry in the templates folder. Now I'm going to copy from the last project we were on. Last examples was in 07, and there was an example, and I'm going to copy this to templates. Let's look to see what that is now. Now what here we have is that we just have the original config map that we started off with in the previous video, right? So it's just a config map, nothing changed. So I'm going to leave that alone for now, the most simple possible example. Okay, so we're going to explore a couple Helm features related to this. So I basically go back out of the project, so I can see the project folder here, right? So that's the project, right? And I can do Helm Lint, it's the first command. I'm going to run it and then I'll explain what it's doing. It's basically checking to see if there was any errors anywhere within your project, which is basically any YAML errors or anything. And you notice it's checked it and it found no problems. So that's the first command we're going to use, which gives you some confidence that your deployment might work, or you're releasing this into your Kubernetes cluster, right? The next command we're going to look at is there's a call. Well, let me copy and paste it, and then we'll see what it's doing. So the command is Helm Install. Well, let me let it play out. Okay. Helm Install. The first entry is the name of it's a little confusing because I've named the revision the same as the chart, but it just seemed convenient, right? And we'll explore this a little bit further later. So Helm Install, the first entry is the name of the revision. That's kind of the instance, name of the instance of this application running in your cluster. And the project refers to a folder, in which case that's the project folder. Okay, so and the key here is we'll be able to install different versions of the project later on by changing the Helm Install project to project, for example, right? But we don't want to do that right now. We'll get to that later. There are a couple of command line options I added here initially. Dry run and debug, that should seem familiar from stuff we've learned so far. It basically doesn't do anything. It just kind of tells you what it's going to do, right? So if you look at this, you can see the name is called project. It's going to go into, this is basically the name of the revision. So the revision is called project. That's the first entry in that command line option. The namespace is going to be default. It hasn't installed yet. And you can see there's another thing. This is going to be important, this revision. So it maintains its own concept of versioning and independent of your app version. So that's what that is. And then main thing here is you can see that it's generating basically a dump of your YAML file that you created. And this is essentially what it's going to install. This is that. Okay, so one thing here too, when you have multiple resources, this wasn't clear until, so you see I only have one resource here, right? If, for example, I had tons, I had hundreds of these things, right? The question is, in what order does it actually build these things? And sometimes order matters. Like, for example, you need to have a namespace created before you can use the namespace, right? There's certain sort of dependencies and instead of you manually defining the dependencies and ordering of things, Helm actually has the best they have is their source code documenting this. They actually have an order in which they install things, right? So when they build your configuration, they basically order all of your things based on the kind of object it is. And you can see that namespace is the very first thing that they'll create. That way you can actually create a namespace and then later use the namespace without running into like a conflict. So there's a whole ordered list, and it's generally designed around the pattern of things at the bottom of the list typically depend on things higher in the list. So pretty much everything that depends on namespace, that's why it's at the top. Okay, so that's one nice feature of Helm right off the bat is you can actually install a bunch of things and it controls the order, so you can actually define a namespace as part of your project or your application, and then use it on the same go, basically same installation. It all goes at once. So that's that's one quick benefit. So let's go install the project right now. And see what it does. Okay, so it deployed it, gives you a timestamp, has a revision number, has a name. So one of the things, let's see what it actually did behind underneath the hood. So I'm going to do a kube control get config map example. And I'm expecting to see, so I see it's there. Let me make sure I'm not missing anything. Oh yeah. But I want to actually look at, look at the actual output itself and see what it did under the hood. Okay, so there's my config map. It's got apple banana in it. It's a config map. Now, pretty much familiar. Let's look in particular at the labels and annotations because those are kind of interesting. One is that the labels, it has one of the app Kubernetes.io. It says it's basically being managed by Helm, so that's good. And then separately, it's got two annotations. And if you look carefully at this, this is talking about the release name and what namespace that release is in. So this is kind of tying it back to the release concept. Okay. Now, in particular, though, one thing you notice here is that you might be surprised is so you're not seeing the annotation, the last modified by, like you would normally see when we did our declarative installs, right? And so the question that's the first observation I had was, oh, that's surprising. Now, interesting enough, okay, so if you're thinking ahead, is like, well, if it's not there, then how do I do delete of things? Because deleting of things like different keys really dependent on knowledge of the previous configuration. So we're going to look at a couple commands here that will kind of shed some light to this. So Helm List, it's a Helm command. So first of all, you notice that Helm somehow can ask, this is actually inquiring of your cluster, and it's getting an idea of what Helm releases have been installed. So it knows that your project was installed, it knows what version it is at, knows when it's last updated, and it's deployed. So there is some concept, Kubernetes has some history about what happened, right? There's some more commands that might be useful. See status, okay. Helm status project. This gives you some details about a particular project, right? The other one gave you a list. So this gives you some more details, right? It was deployed, right? And then there's another command, get all project. Now here's where this is really interesting, is that somehow Helm has access to, it knows about the project, but it also knows about the last known configuration. This is essentially, this is the last configuration that was given, and it ties it back to the original source. So this data is not coming from my machine. This data is coming from the Kubernetes cluster. So even though it's not stored in the object in that annotation, there's some notion of Kubernetes knowing about this config map. And this is how it can do things like remove, when you do removals of things, it can look at this data. Now, I had to do some poking around, but it turns out that this data is kube control get secret. So the way that this is actually managed is that Helm, under the hood, maintains secrets, which we haven't really talked about, but it's basically just encoded key value pairs, right? So it's basically a little database. And you can see that Helm is using, right, right here, right? It's storing data, and it's tied to your project and your release, right? So this is basically project, and it's a release of the project. So this is where the configs are stored, and I'm not going to go undo their stuff, but conceptually, this is where Helm is maintaining the data that is going to allow you to do things like delete keys, and we'll even see you can actually delete objects too, which is something we couldn't do previously. Okay. Okay, so the next thing you typically will do is you want to make a change to your application, and then redeploy it or reinstall it. So let's go through the exercise. Let's say we're going to delete A, and we add cantaloupe. Right, so I'm doing an add and a delete to illustrate that it does indeed do adds and deletes, more importantly. So the first thing you're going to do here is get back here. Yep, here. Okay. Let me copy this. I'm going to do a dry run here and see what it's going to do. So I'm doing Helm upgrade project. That's the revision. Project's the folder, right? And you can see that the final result does show you that it's got no A and it's got a C. But one of the things, it's not really clear what the change was. So it turns out that there is no diff concept within Helm itself, but there's a third-party library that you can install, which you can install yourself. It's called a Helm diff plugin that enhances Helm with a concept of diffs, which, to be honest, I don't know why it's not built in, to be honest. So I added it, so you can add it yourself. So now I'm going to do another command. Now that I've done that, I'm going to run this command, Helm diff upgrade, project to revision, and then the project is the folder here. And let's see what that outputs. Takes a little bit because it's now doing more calculations, but this gives you a nice output, right? It says, hey, this example is actually being changed, and it precisely tells you that you're removing apple and you're adding cantaloupe. So that's perfect. It's exactly what we want to know. So now that with the confidence that I know what I'm doing, so now I can do Helm upgrade project. And that's going to deploy those changes, right? So it's going to add and delete. And it tells you now you got a new revision called 2, and just validate this. So kube control get config map example out YAML. And indeed, you can see the A is gone. Now there's a C, right? Nothing else fundamentally has changed in here, though, right? So this is not maintaining the history in the object itself, right? So, but there's a couple things we can look at here. So first thing we can do is look at Helm List again. Now you can see that I've got a project on revision 2, and another interesting command is Helm History Project. This will tell you the history of that project, and you can see that when version 1 was installed and was replaced, superseded, by version 2, right? The app versions, again, conceptually I would have changed the app versions, so this didn't stay the same, but it's actually using its own revision counter anyway, so it's not critical, but it's good practice, right? So that's that. So we learned about history. Oh, right. So one of the cool features of this too, so let me do the Helm history again. Oh, history project. So let's say you figured out that, oh, that was a mistake and I needed to roll back to my previous version. So instead of having to go back into the config files, somehow figure out how to revert your files and then, you know, push a new version, you could actually just do a command, Helm Rollback. Actually, give me a second. Oh, before I do the rollback itself, because I have diff installed, I actually can do a command called Helm Rollback, Helm diff rollback project. So, oops. Oh, so I want to know what's going to happen when I roll back project to revision 1, right? And you can see that it's going to tell you what exactly it's going to do. It's going to go back and add in Apple and remove Cantaloupe. So that would mean, so if I do now Helm rollback project, right? It's going to roll back to the previous version, and Helm history. Oops, Helm history project. And now you can see that what it's done is it. So by the way, when it rolls something back, the history is immutable, right? So it actually deploys a new version, right? Now I'm on revision 3, and it deploys it, and it says it's rolled back to 1, right? So now if I do kube control get config map example, I can indeed see that it's now back to Apple Banana the way I expected it to. Okay, so that's a super handy feature. Okay, so so one thing I want to do here is I want to explore one of the features that we did not have when we were doing just with kube control. I had no easy way of deleting an object other than just imperatively deleting that one object, right? There was no concept of deletions were basically imperative. Now it turns out that Helm has sort of a declarative approach to deleting, because it actually knows about this concept of revision, just knows about not only your one object, but it knows about all the objects that you're trying to manage as a group. And that allows you to also not only delete individual key values, right, keys of an object, allows you to actually delete whole objects. So let me just illustrate that by example. So I'm going to go into my project. I'm going to go into my template. So first I'm going to do is I'm going to copy example to example 2.yaml. I'm going to edit this because I can't have the same name. Excuse me. And I'm going to make it back to A, Albany, B, Boston. Okay, so let's do this. Okay, I'm at my project folder. I'm going to first see if I try to apply this, what the changes would look like. So I do Helm diff project. Oh, upgrade project. That should tell me what's going to change when I apply this project. Now you'll see a couple things. First of all, since I never change my files, right, this doesn't undo the rollback because I'm redeploying essentially the latest version of my code. That's why Apple's being removed and Cantaloupe's being added. But here's now it's going to add a new object. So that's good. Helm upgrade project. And with Helm and kube control, now I'm getting my commands mixed up sometimes. Okay, so now, if I do a kube control get, you can see that I have my two config maps, and they are what you expect. Okay, so that's good. Now the key here is what happens now if I wanted to remove. So what happens now if I want to remove example 2? In the previous world with kube control, deleting the file did not actually, cause it to delete, because it didn't know what to do. It wouldn't actually delete the object. And as you guessed it, in this case, it does work the way you would hope. That is, I can go to my templates now, remove example 2, and I can now go through the exercise of kube control diff upgrade project. This will tell me, not kube. See, this is where I'm already getting myself confused. This is Helm. Let's see what it says. Hey, it says it's going to remove the config map, exactly what we wanted. So then I can apply it, kube control, god dang it, Helm, Helm upgrade project, and that should delete. Then kube control get config map, and I should only have one config map now. That's the example one, right? So that's perfect. Okay. Okay, so far that's most of the flow, right? You just keep on upgrading, right? And rolling back and upgrading. One of the main features of Helm is the ability to use variables in your config files, right? In your YAML files. And we're going to use the example, if you remember before, let me bring this up. Previously in the last video, I think it was, we talked about Kubernetes recommending certain labels around the concept of an application, right? And like, for example, they have the name of the application, the instance of the application. This should sound familiar, by the way, right? This is very much like the chart, and the instance is like the revision. The version, well, we have a concept of a version of our charts, right? So, now component and part of, our little example is not very complicated, right? So we don't have a big project when these have components. So I'm not going to use, in my example, I'm not going to bother with component or part of. And you noticed, if you remember, that this managed by is already being added by Helm, so I don't have to worry about that one. So I'm going to go in and now change it so that I'm using these labels, name, instance, and version. So, and to save me some typing, I think I'm going to copy. I think if I do this right, so remove project template example, right? I'm going to remove that, and I'm going to copy from my project sample template example to project template. Right. Okay, so I'm going to look at this real quick. Let's look at what this new file looks like. Project chart example, right? So I just added, basically I'm back to my original apple banana example, right? But I've added in 3 extra labels that weren't, and I changed the name. So let's talk about the name first. Because conceptually, this is an application, right? This chart. And conceptually, I can release multiple versions of it, and that's the concept of the revisions, right? So when you do that, you got to be careful about name collisions, right? And I want to make sure that if I deploy this application in the same namespace, I don't have naming collisions. And so the trick here is I'm using a variable, right? This is basically this double curly braces, right? Basically is a template instruction saying use the release's name, right? Because the releases have names. We're calling it project, right? Use the release's name as part of the name of this object. And that way, if I have two different revisions, then they both don't have, then my names and my objects don't collide. And I guess one key here is you can't have the same name. In one particular namespace, the revision's name is unique. So you can't have two revisions of an application in the same namespace that have the same name. So this is one good way of creating unique names for my objects in my chart. Okay, along the same vein, right, I wanted to create these name, instance, and version of my application, right? And so in this case, the chart name is the name of the application, right? Because this is basically referring back to the sort of the source code, right? Where did this come from? And the release name is sort of the instance that I'm actually installing. So this actually fits nicely. The two concepts fit well nicely. And of course, our chart itself actually has a version. We haven't been updating it, but there is a concept of a version, and in theory, we should be updating it. So we can actually populate the version right from the chart version. So essentially, you will notice that the best practices of Kubernetes with using these labels fits really well with Helm, because that's exactly what Helm does. Okay, so with that in mind, let's deploy this and see what we get. So if I do Helm diff upgrade project, so first of all, you notice it's deleting the other example. That's because I changed names. So the old name was name, it was example. So that's no longer an object. Now it's called example-project, and you can see all my variables all filled out. So it looks like this is going to go good. So now I can do Helm upgrade project, and then that will upgrade my revision, right? And now if I do Helm List, right, I can see I'm on revision 6 already, right? And if I do, say, kube control get figmap example dash project output YAML. Oof. And now you can see the data's all right, and now I've got my additional labels, and my name, of course, is now named. So it did exactly what I wanted. We can do one more thing, right? I think this is the last thing. Make sure I'm not forgetting something. Yep. Okay, so I'm going to do one thing here. Helm List. So first of all, you'll notice that I have one version, a revision project, right? And it's based on the chart project. Now, what I can do is I can actually deploy another, now that I've got my, won't have naming conflicts because I did my change here, I can actually do Helm Install project 2 from project, right? And let's see what that does. So now I installed a revision called project 2, and if I do my list, you'll notice that now I have project and project 2, right? But they're distinct, and they're both based on, though, the project chart at a certain version number, right? So, let me see, right. Now, the last thing we'll look at is just to see what's in chart, the actual data, the actual object I created. So if I do kube control get config map example project 2. And now you can see I still have Apple Banana like I expected, right? But you can see that here the annotations say it's part of project 2 now, and you can see the things I added here, right? Yeah, I can say it's part of the instance of project 2. Its name is which is the application's name is project, and my version is 010, right? So okay, that's about it for that. So now you can see that Helm List, you can see that you can have different versions or revisions of the same application running. If you set up your config files, your templates have to not have naming conflicts, then you can do this. Okay, the last thing I'm going to do is we're going to uninstall these. So all you got to do is you just got to run Helm Uninstall project. And you can run uninstall project 2. And now, if I do Helm ls or list, you get nothing. And of course, if you do kube control get cm, there's no config maps. So I basically backed everything out, so completely clean again. Okay, so the only thing else in here, I kind of breezed over it, but so far in this example, we were working all out of our default namespace. But the revisions themselves, they're actually namespace kind of objects. They're actually using secrets under the hood, and secrets are namespaced, right, to keep track of the data. So if you want to deploy your revisions in different namespaces, right, you can use the namespace option as part of these commands, and that'll work. That all that data gets stored in basically the different namespace. So that's something to keep in mind. Okay, I think that's it for this video.